welcome back to my channel. I hope you are liking my videos, you're subscribing, you'll share, you'll comment your opinions on the class, your doubts, etc, and I'll be happy to solve the same and talk back to you, comment back to you. So without much ado, I'll be moving on with the next part of ray optics class. That will be about prism. So prism is a triangular reflecting object. No need for more introductions. One second. Sorry. Yes. Yes, we're having a triangular prism. Now what happens? Normally an incident ray is here. Yes, refraction happens. And yes. Refracted ray. Angle of emergence, two refraction angles, and I. This is I, it's entering, and there is an angle of reflection. Now from denser to rarer medium this is going. Really this should be some I and this should be R, but I just changed it as second angle of refraction 2 and angle of emergence. Emergence means angle of going out. And there is an angle for the prism. Okay. Yes. Now this angle of prism is found out to be R1 plus R2. That is the both angle of refractions. And there is a deviation for this incident ray from the emergent ray. That is this deviation. This deviation is found to be I plus E. That is incident angle plus emergent angle minus angle of prism. That is R1 plus R2. Okay, very important formula. These two formulas are most important in this chapter. Now if we are drawing a graph for I versus deviation, I versus deviation. Once again, I'll draw it about better. I versus deviation. Here will be deviation. Here will be angles. We'll get a graph like this, a parabolic graph. If you note, at one point we get I, angle of incident equal to angle of emergence, and that point is found to be angle of minimum deviation. The angle of the deviation is minimum. Minimum is least deviation, minimum. So this place for minimum deviation can be calculated like minimum equal to I plus E minus A. Here I is equal to E, so angle of minimum deviation is 2I minus A. Very important. And in angle of deviation, one more specialty is there. R1 is also equal to R2. So we can write R1 plus R2 is equal to A, and 2R will be equal to A. Therefore angle of refraction is equal to A by 2. And angle, now from here angle of incidence is equal to delta minimum plus A, and angle of incident is equal to delta minimum plus A by 2. These two things we noted. Now if we are applying Snell's law, that you know that angle of incidence, angle of refraction, you know that sin I by sin R equal to mu 2 by mu 1. Here mu 1 is 1 because it is air. So sin I by sin R is equal to we'll give just mu, that is refractive index of the glass. Sin I means sin of delta minimum plus A by 2 by sin of A by 2 is equal to mu. Very important formula, should learn by heart. Relation, I'll mark it. Yes, very important formula. Okay. One second. Yes, so next, this is the most important in the following chapter. This formula is the most important in the following, in this part. Okay. Yes. Now we'll be talking about thin prisms. It is a special type of prism. Thin prism. Okay. Thin prism. A prism with very small angle of prism is called a thin prism. Look here, angle of prism is very small. Small angle of prism is called thin prism. For a thin prism, we are going to derive something. You know that for a prism, for a normal prism, plus a by 2 by sine a by 2 is equal to 0, mu. You know that as angles are very small, we can just write them as sine theta will be approximately equal to theta when angles are small. But the trigonometry approximation. Okay, so we can write the following as this. For a thin prism, a by 2 is equal to mu. If you rearrange, you get that angle of minimum deviation is equal to 2 will be cancelled, a will be going here, a mu, and this a will take in the other side, a. Therefore, for a thin prism, minimum deviation is equal to a times mu minus 1. Very important formula. So, this is another important formula. This part is having many important formula. So, if you are forgetting or if you are planning to leave this formulas, it will be difficult. Just learn this formulas and keep and just understand the concept. That's what we need. Okay. So, this is a formula for minimum deviation for a thin prism. This is only applied when the prism is having a very small angle of prism. Otherwise, you should use this formula. If 60 degree, 30 degree, 45 degree and all, you should use this equation. But if it is 1 degree, 2 degree, 5 degree and all, you can use this equation. Okay. Yes. So this is about thin prism. Now we will be talking about dispersion of light. Dispersion. I don't know if this part is there in the syllabus. I think it is not there. But still we'll we'll understand what is dispersion of light. So it will take some time because I want to make it colorful. We'll be just learning dispersion through a thin prism. Okay. That is preferred. Okay, this is the thin prism. Angle of prism is A. Now incident ray is falling. What happens? Here they split into different colors, but I am just giving only one color. Like they split into red is extreme color. Next one will be yellow and violet. Now they will be coming out like this. Why I give yellow, orange and red? Because yellow is the mean color, red is the one of the extreme end, and violet is one of the other extreme end. So like this it will be coming out. Other colors will be also there. Okay. So this is the thing. So understand one thing. What is the degree of, like, what is which color among these following dispersed the most, or deviation is most for which color? Most for which color? Very simple. Deviation is most for which color? Yes, violet color has more deviation. Violet color has more deviation. Then it is yellow, then red. Very important order. Okay, and this same deviation, this deviation thing, if you notice something, you can understand that which of the following have greater wavelength? Does violet have greater wavelength or red have greater wavelength? Does violet have greater wavelength or red have greater wavelength? Red has longest wavelength. So this shows us that deviation is inversely proportional to wavelength. If wavelength increases, deviation decreases. Wavelength increases, deviation decreases. So for which of the following speed is the most? Yes, speed is. So this also means that deviation is inversely proportional to speed of the color or speed of the light. Okay, very important relation. Okay, now we have angular dispersion. Important topic. Important means it's simple to understand but important. I'll just copy paste the same image, copy, and I'll paste it here. Yes, I'm having the image here. Look, I'll just erase this yellow line. Angular dispersion just means the angular difference between the extreme wavelength colors. This angle, this theta, this delta theta is called as angular dispersion. The angle between two extreme wavelength. Okay. The formula for angular dispersion is A mu of violet minus mu of red. The problem here is that this is for a thin prism. Usually they only ask for thin prism, but if they ask for the normal prism, you have to derive it from the above sin theta, this formula you have to derive this. Okay, it will take time. So for thin prism, this is the formula. How did we derive it? It's very simple. Delta theta equal to dispersion of violet minus dispersion of red. Dispersion of violet means A mu v minus 1. You know, this deviation is equal to A mu refractive index minus 1. So they just minus the same, and by rearranging it we'll get A mu v minus mu r. Okay, simple. Very important formula, but simple but humble formula. Okay. Yes. Now the next thing is dispersive power. Dispersive power. Dispersive power means angular dispersion by deviation of yellow color. It is called the dispersive power. Why deviation of yellow color is used here? Because yellow color is mean. It is in the middle of the rainbow spectrum, or middle of the visible light spectrum. It is middle. Look, violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. Approximately yellow's wavelength is the average of all. Therefore yellow is chosen as the mean color. So dispersive power means angular dispersion by minimum deviation of yellow. So dispersive power equal to angular deviation. So all we are deriving for a thin prism, angular deviation, that is A times mu r minus mu v, r means red, violet, by A times mu yellow minus 1, because minimum deviation formula for a thin prism. A cancel. Therefore dispersive power equal to mu r. For dispersive power we use omega as a symbol, or W as a symbol. Mu r minus mu v by mu yellow minus 1. Very important formula, dispersive power. Very, very important formula. Okay. Yes. Dispersive power for a specific medium will be same. For a glass medium it will be same. It is independent of angle of incidence. Right? Yes. So now by this all the things about prism come to an end. This much about prisms, and by this all the thing about prism come to an end. And next part, please share the video, please subscribe to the channel, please like all the videos, and only then our content will reach to many people, and many people should be enlightened by our content, and their knowledge should be improved by me. I hope for that. Please like, share, subscribe, send it to your friends, and make this program or make this YouTube channel a big success. Okay, so that everyone can learn, for everyone's well-being. Thank you for watching the video. Next part we will be coming up with curved surface refraction, that is lenses, etc. Okay, thank you.